Welcome to a new short video series on base building. This series is going to be cut into 3 short parts, creating a piece of a building all the way to being able to snap it and control which snap point we want to use to connect the 2 buildings together. And to start that off, we're going to go with a first-person project. It's going to be completely blank. We're going to be starting from nothing, and we're going to be building it in blueprints only. This is going to be in 5.4, and I believe 5.4 is mandatory here for one of the elements that we're going to be using for the snap points. So please keep that in mind. Go ahead and name your project whatever you want. In my case, I'm going to call it base building. Obviously, this can all be done, or how we're going to set it up, we're going to be using mainly actor components for all the controls. So if you want to do this on another project that you're already using in version 5.4, that's absolutely fine. All you'll have to do is add the component to your current character, and the rest will all work just like that. With that in mind, once the project loads, I'll get back to you, and the first thing we'll probably do is import the asset. So if you want to go ahead and open that on the Google Drive, then I would suggest doing that. There we go. So now that the project is loaded, the first thing we're going to do, as I do with any project, and I would suggest doing in your case, is just keeping things organized by adding a folder for it. So we're going to be calling this base building, and that's exactly where it's going to go. So double click to open that, and the first thing we're going to do, as I mentioned earlier, is we're going to get our assets. So that's out of the way. So just call it assets, and what we'll do is we will import them right in here. So drag and drop them in. Everything by default is good, just import all. And you might get an error for the no smoothing or degenerate tangents. This doesn't matter too much. It won't impact at all how this works. It's just that I suck at making anything in Blender. So it's very basic, and the UVs haven't been done, and anything like that is kind of been skipped. So that's why you get these little errors here. So Control-Shift-S just to save them all. And we can close the content browser now. The next step is we are going to make every element that we're going to need for the project. So next to our assets, we're going to right click. We're going to say blueprints first. Then we're going to add our inputs. And finally, we're going to add data assets, because we're going to be using data assets to store the information from each of our building pieces. So for each of these assets right here. So in the blueprints, we're going to create a few actors, or an actor first, and this is going to be called A_builds. So what this is it's going to be the actual element that we're going to place in the world, and we're also going to use it later to set up the snapping points in the editor so that it's easier to use or easier to set up than it is to just have to type those numbers in on a transform array. Next, we want to make a blueprint class for our actor component. So right here, actor component select, we'll call this AC for actor component, and we'll call it, I just put tool. That's what it is. It's a tool to use to make buildings. So what this is it's a component that we can attach to any kind of actor. In most cases, it's going to be the player, because this requires player interaction. But this way, if ever you want to, for instance, let's say, take this logic and move it to another project for something else later, all you would have to do is attach this to your new character in the other project, and the rest would just work without any problem, as long as you move the whole folder of base building, obviously. Next, now this is just because I need to make a new character, so if you're following along with an empty template, you're gonna have to do the same thing here. We need to get a character we can use. Now we could use the first person, but it's a better practice to just use a child of the first person here. So we're going to look for first person character. So this one right here. Open it, and we're going to call this FPS builder, we'll call it. And this one is going to be just pretty much our first person character, and we're going to attach the AC tool to it. And that's all we're going to do there. That's just so we can show how to attach a component, and also so that in the level we can select this instead of modifying our parent class, which is the FPS controller character itself. 2 more things left. We need another blueprint, is a game mode. So search for game mode here, and we're looking for game mode base will do just fine. We could use the first person, but it's not necessary. Not much happens in there, so we'll just make a new one. and this will be GMB building. And with this, it's just used to inform our level here. By setting in our world settings, instead of this game mode, we'll be using our new one right here. It's just so that we can set which character, which controller to use, so that we can actually just use our new FPS here instead of using the first person one. And the last thing we need is going to be our snapping points. Now, for now, I think I'm going to leave those out because this part is going to be focusing on the builds. So we're going to make it, we're not actually going to use it just yet though. So this is going to be a static mesh component is what we're looking for. So not this one, we're looking for this one, the static mesh component. So select this, SMC for static mesh component, and we'll call it snap. And it should look just like this. And one last thing we need, but also we're not going to be using just yet, is going to be a structure, which is going to contain information for snapping and more specifically filtering, which we'll touch on in the third part. So we're just going to make that for now and we'll leave it on the side. So in our blueprints here, we want to look for structure and we'll call this ST for structure and snap point for it. So we can save all this. And the first thing we'll do is we'll just set up our character to check that it works. So actually, before we go and open this, we're going to make a new level because this one can sometimes have some issues when you close and open the project. So we're going to make a new level by doing Control N. And we're just going to get a basic one. We don't need much. It's just somewhere where we can work. So now we just do Control S to save it. And in base building, we'll call this L testing level. There we go. So we have our new level. Now let's get to our blueprints. So our FPS builder is what we're going to use to control. But just to check that this is working, we need to set up our GMB first. We need to know which game mode we're using. Now, by default, a new level doesn't have any, because the project itself already has a game mode. This is just an override. So we're going to select that and set it to our GMB building. Now, if we open GM building, we'll get this screen, which is pretty much the same. It's just the default class, or the class default, sorry. And we need to change two values in here. The first one is we need to change our controller, and that's because the default player controller isn't very useful. So we want to add our BP first person, because that's all we need. It just allows us to actually move. That's what it's for. And the second one is we need to change our default pawn class. And now, if this were the first person game mode, then it would be the first person here. But we want to use the building one, so we're looking for FPS builder. Now, to check if this worked, we check here, we've set it. All we can do is add a first person, our FPS builder here, and on our event begin play, let's just add a print. And there we go, we get a hello because this is the player. So now we're not going to touch our player anymore. The only thing we need, so that we can close it and never touch it again, is we're going to look for our AC tool. So look for that in here. It should be in custom. Select it. It will appear here. No information or anything. We don't need to touch anything. And right now, instead of having to handle everything in our builder, we're going to handle everything inside of our tool. So close our builder and close our game mode. We don't need that either anymore. And to check if this is working, we'll do the same trick as with the builder. We'll do a print in our begin play. So let's play, and we do get the hello message again from here. Let's close all this. Before going any further with our tool here, we want to make a data asset. And so that data asset is going to be used to contain information about each different piece that we have. So we're going to go and look for blueprint, and we're going to look for primary data asset. So this is the one we're looking for, not this one. We can't use this one. We want to use the primary one. And we'll call this DA underscore blueprint, because that's what it is. It's going to be a blueprint for each piece. So open that up, and this is kind of where the basics of everything is going to go. The first thing, and pretty much the only thing we're going to do for this video, is we're going to say which static mesh are we using. So this is going to be static mesh. And one thing to note, which I didn't mention in my data asset video, and that was a bit dumb on my part, to be fair, I learned it after the video, which is stupid. is when we're working with anything in a data asset, we want to make sure that we're using soft references. Now, I'm not an expert on soft references, but it's just a way to avoid preloading assets without the need to do so, because currently the data asset is sitting blankly. We're not going to be using it until we specifically call that item to spawn. So until that point, we don't want to load any of the assets within the data asset itself. So what we're looking for here is a static mesh, and we're looking specifically for the basic one, not the component, not the actor, just a basic static mesh. And normally I would have taken an object reference here, but what we want to use is a soft object reference. So select this, there we go, and it just looks slightly different. And now in 5.4 you can actually change this very easily here. So this is all we're going to use for now, and I'm going to show you how to load it in a second so that it actually works with our actors. So we can close that now, and we're going to make our first data asset here by going right click in the same area, go down to miscellaneous, and get data asset. And now we get to actually choose from all the data assets that exist, and we're just going to choose our DA blueprint. So we'll call this also DA, and we'll call this floor, and open that up. And here we can still select it just like any normal asset. It's exactly the same thing. And to make it easier so we don't have to search through, because there's quite a few floors, I believe, we're going to open our assets, pre-select our floor, and click on the use selected asset from content browser. And now we have the floor. One last thing we need to set up before we can actually get into the controls and actually before we get into the blueprints is the inputs, because without the inputs we can't actually interact with the world. So right click, go down to inputs, and we're looking for input mapping context. So IMC building will do. Next, we need our inputs for that. There's going to be quite a few here. So input action. First one is going to be IA confirm. And this is going to be used to let the building know, or let the construction know, that we want to confirm that placement, that we want to have it be there. This by default should be Boolean, and that's correct, because for the IA confirm, we're just pressing a button. If it works, that's all. We don't need to check a value or anything. We don't need to scroll the mouse wheel, so we just stick with a simple Boolean. So we can get rid of this. We don't need any more for now. And let's make another one. So we're going to duplicate this, and this is going to be called IA freeze. And we're not going to be using this in this part, but in some of the later parts, we're just making it here for now. Next, we're going to make an IA underscore build select. Now, build select is going to be a float. So open it up and change the value type from digital to axis 1D. It's like that, and we can close it. And what this one is going to be used for is so that we can select, instead of having an input for instead of having an input action for 1, 2, 3, 4, and 5, we're going to use build select, and in our input mapping context, we will say for the inputs 1, 2, however many we have, in our case, I believe it's 6, we can actually multiply the value and have that number come out, and we'll use that to select from a map which actors we're trying to use. Now, the next input we need after freeze here is we're going to need another duplicate of, well, actually freeze or AI or confirm is fine. We need a Boolean again, is the grid. And this one is going to be used. It's for snapping to grid. If we want to, instead of freely moving the item we want it to be every 500 units, we hold this button down and it will do exactly that. Next, another one, duplicate of the grid, is going to be the snap. This is going to do the same thing as the grid, except instead of snapping to every 500 units, we're going to try and snap to the closest, or the item that we are hitting. And the final one we need is rotate. So this one is going to be also a float, and this is going to be the mouse scroll wheel to rotate the items that we are holding, or that we are trying to place. So the last thing we need to do to get our inputs working is we need to add it to the IMC building. So mappings, press the plus and it will appear right here. And we want to just start off by adding our confirm. Now we'll start with our select, because we want to have our list here. So select the keyboard and press 1. And to make sure that it is one, we're going to add a modifier. The modifier we're going to use is the scalar. And make sure you expand here by double clicking or by clicking the arrow. And here the scalar is 1. We don't want to touch it because we are clicking the first key. So then to add a second one, we want to go next to our IA build select, press the plus, and we will add 2. And once again, we want to use the same scalar value here as a modifier. And we will put 2. And we can just keep doing this for the 6 that we have. So that's 3. Add another modifier, scalar. And this is 3 instead. And we'll just keep doing this for all 4. So for all 6 of them, sorry. There we go. So that's all of them loaded. Now we can make them smaller because we don't need them anymore. And we will click plus to get the next one. And what we're looking for now is we're going to get the confirm. So with the confirm, we'll be able to say, well, if we left click, then we want to say that we want to place the item. And the next one, I believe that is enough. Well, no, we want to add the rotation, sorry, as well. So once again, the plus. And we look for rotate, and for rotation, we're going to get the mouse wheel. Now we don't need to do anything here for either of these because this one's a Boolean, and this one is simply the mouse wheel axis, which will be from -1 to 1. We don't need to touch anything for that. Oh, I'm sorry, last one I completely forgot. We do need to know whether we are using the grid. So once again, the plus here, it will appear down here. Select the grid and go down, and for grid we'll use control. So if control is pressed, we're trying to snap the grid. So nothing here again, that's all fine. Collapse these, and we are done with our building for now. We'll add the next ones in the next part once they're needed. So now in our AC tool again, the first thing we're going to need to do is we need to get our player controller. From the player controller, we want to get enhanced input local player subsystem, and we will be adding our mapping context through this. So right here, and the mapping context we want is our IMC building. Now the first thing we need is our build select here. So we're going to get that one first and we'll start from there. So build select, IA build select is what we're looking for. And we're going to use started here. And so how this will work, just so we can see how it works, let's print. Normally, if we press any of the 1 to 6 values, we will get this appearing here. So what we're looking for is our action value. Make sure you choose the top one here, not these, because these are different. And we're specifically going to see if we can get our 1 to 6 value here. So if I press 1, we get 1. If I press 2, we get 2. If I press 5, we get 5. In any order, it doesn't matter. It understands that we're pressing those specific keys. Now, next, we need to tell, well, what actor are we trying to create with this information? Now, currently, we only have one data asset. So for now, we'll just use that one. That's fine. So let's create our map to get that information. So we'll call it building map. And building map will be an integer to start. And the reason we're using an integer and not a float is because the float can sometimes be slightly off. And when looking at a map, that's very important. We don't want to have even the slightest error because otherwise it won't find the information we are looking for. So with our integer here, we're going to go to the right and we're going to change it to a map. And instead of a second integer, what we're going to look for is DA blueprints. Now it should appear about right here. And we want to use a soft object reference because we don't need it to be preloaded. We only want to load it once we actually create it, so when we spawn it, so to speak. So compile and save. And with that, right here on started, we can now say that from our action value, we can round that value. And in our building map, we can bind that value. And so now, with this alone, we can say based on our input, so 1, 2, 3, 4, 5, 6, 7, or in our case 6, we can get a specified building that we're talking about. And then we will be able to spawn it through here. Now we're going to make a quick function for this because it's easier to read. But let's first add our actual element. So by selecting our building map or selecting it here works as well. Click the plus, and 0 doesn't exist, so we want to do 1. If you have 10, you can use 0, that's fine. And we'll just select the A4. Now there's no point in adding any because we don't have any extra yet, so we're just going to stick with this for now. There we go. So with this, we now need to inform our new building or our new piece that we want to create it. So I'm going to press R to add a reroute here. Then I'm going to select it, right click, and collapse the functions that we have an input already made. This function will be called spawn new build. There we go. Connect it on started. That's where we want to use it. And we will double click to open it. Now inside of here, we need two things. One thing first is we need to know if we already have a build that we are using, because if you have already placed a build or are attempting to move a build, let's say, and you try and create a new one. So let's say I have a floor already present and I don't like floor, I want to change it to a wall, and I press 2 to change it to a wall, then we want to make sure that we delete the old one. We delete the floor because we don't want to move it anymore. And if we leave it there, it will have an error because it will be trying to move something that doesn't exist. So the first thing is we need to get a reference to that building. So we're going to make a new variable, which we'll be calling building reference. And that's exactly what it sounds like. It is a reference to a building we are trying to make. So it's going to be of type build, I believe we called it, a build. So this one, we do want it to be an object reference and not a soft one because it's actually placed in the world. It exists. So we want to make sure that we know that we have a reference to something that exists in the world. So change this to a single. We don't need a map. And the first thing we'll do in our spawn build is check, does this item already exist? And if it does, we're going to destroy that item because we don't need it anymore. It's been replaced. Now, after this, we're going to do a line trace because we want to check in front of the player where he's trying to place his item. Now, we want to do this on is valid or is not valid. The only difference is we want to delete the old one if it is valid. So we just do some reroutes, have it be nice and tidy. Now, next, we're going to make a line trace. Now, this line trace is going to be turned into a macro in a second. So let's just go ahead and make it first. For this to work, because of how the tool works, it's based on the player character. So we can take the get player camera manager instead of having to cycle through the information and say, hey, here is a camera that we can attach, like get child component. We don't need to do that because we know it should be connected to a player because we have player inputs. So we can just do this directly. Now, if you're in multiplayer, this might be a bit different. So here we want to say get actor location. And this is going to be the start point of our line trace. So we're going to do line trace channel. And this is going to get plugged in here. And for the second part, for the end, what we need to do is we need to add to our start our forward vector here. So we're going to get a forward actor vector here. And we can't just plug this in directly, otherwise it would be a tiny line trace, like 1 unit, and that's not enough. We're going to multiply it by 1,000. So that's the range that I use throughout this video. If you want to turn this into a parameter, that's absolutely fine. It probably would be better to do, you know what, we'll actually do that. We'll make a parameter, so promote, and this is going to be our range. And the range should be by default 1,000. There we go. So just set it to 1,000 in case it isn't. And now we put this into the end. Now, just to check if this is working, we'll put a debug for duration and we will try and print. So we'll try and do a line. So if we press 1, we get a line trace. If we press 2, same thing. 3, 4, it doesn't matter. We keep getting that information through. So our line trace is indeed working. Now, we're going to add a reroute here, a reroute here, and a reroute here. And just so with that, we can do right click by selecting everything, collapse to macro, and this will be our line trace by channel, and then we'll put FWD for forward. So we do this because we're going to be using a few times the same line trace, so we're just making a macro out of it because we don't need it outside, we only need it locally. So we'll just use it here. So with this, we now get to say where to spawn our build. That's the immediate thing we do here. So the first thing is we break out our impact point. We need to know where we hit. So then we can say spawn actor from class and let it know where it can spawn. So click on our spawn transform here, right click, split struct, so we can just plug our impact point here directly in. With our transform here, we don't want to just directly plug, or we don't want to leave it 0, because if we spawn it and the player is, let's say, looking not straightforward, it kind of looks weird because the thing always spawns at the same rotation in the world. So what we do is we are going to get our owner here, which is the player character, and we're going to say get actor rotation, and we'll use this. So plug that in here. Now, one last thing we need to do here before we go any further, or we can add this first, is we want to let it know that it has an owner. And the reason we need this, and to be fair, in my project that I'm looking at right here, the owner doesn't exist. I'm talking about the instigator normally, but I'm assuming it's going to be the same thing. It shouldn't matter too much. So we're going to say that it is owned by the player character, so that if we ever, or later when we're working on the snapping part, we're going to be using the construct script, and we'll use the owner to say if it doesn't have an owner, then we're using the construct script. If it does have an owner, we don't use the construct script. So we're just missing one thing here for this to work. Well, two things actually. We need this to be a builds, because we haven't selected the class yet. So select the class a builds. No, sorry, we don't want this to be owner, we want it to be instigator. So this won't work anymore. What we need is we need to convert this to something that is valid. So that is a pawn. So cast to pawn. And because this, once again, is attached to a player character, it always will be a pawn. So we can right click, sorry, I did that a bit quick. We can cast this to pawn, and because this won't work, so we don't have any executions, we can make it unsafe by making a pure cast. So don't do this unless you're certain that it's going to be on a player character or a pawn of some type, which it should be in our case. So this should work in most scenarios. So one thing we're missing here is we, on purpose, put an input pin here, but we're not using that. So we need to go into our build here and make that input pin appear so that we can transfer the information of which asset or which data asset we selected. So right here, we can do our search button, our browse, and we will open our A builds here. So we want to double click on it, and we're just going to start by making that actor for us. So, or that variable, sorry. So this is going to be data assets used, and it's going to be DA blueprint like the other one, and we want to make sure we choose a soft object reference. And we can't just leave it like this, because if we leave it like this, it won't be visible. So to make it visible, we can do this. Now, this alone, which is instance editable, will make it visible for in editor. So let's show you how that works. If I drag a build in here and I go into details, I can actually see our data asset, and I can select one. And that just means that every individual one I have in the level can use a different reference. So here, if we switch between the two, this one doesn't have a reference, but this one does. But to get it to appear here, for instance, we can actually do that by selecting the same variable and also selecting expose on spawn. Now, both of these need to be true for this to work. So compile, save, and now we have our data assets to be used. So let me just line these up a bit, and we can get our input pin, I believe we called it, and just plug that straight into here. So once again, line that up. There we go. So now, if we play and we press 1, that will have created a builds for us. So I just pressed F8 to quickly get out. So we have a build, and it also does have our floor reference, which we told it to use because I pressed 1, but it doesn't know what to do with it. So let's make it so that we can actually use that build. So in our event graph here, we're going to get rid of our event actor begin overlap, compile, save, and in our event begin play, we're going to use this. We're going to check is valid soft object reference. And the reason we do this is because maybe if I clicked on 2 there, it wouldn't be a valid reference and it would not work. So we'll say if the reference isn't valid, then we will just destroy the actor. So that way it is solved, it knows it can't exist, it will reset itself. So the first thing we want to do is we are going to turn this into something that is usable, because right now we can't get our static mesh. It doesn't exist because this is a soft reference, not a hard reference to an object. So to do that, we want to say load async asset. Now what this will do is it will allow us to load this on a different thread, but I'm not going to get into that because I'm really not an expert as far as multi-threading goes. But this will allow us to load it without blocking the whole script or the computer, just load this asset. Now, please note, even if you do use the load like this, because we're not doing much, it shouldn't cause any issues. But if you're doing this on a larger scale, you need to be careful and really look into the difference between the two. So here, our object is not what we need. Right now, it's just a basic object reference, and we need it to be a data asset. So we're going to grab this here and say cast to data asset, sorry, not data asset, DA blueprint, and we'll use on completed here. That way we're sure we need to do it on completed because this is the asset we're loading. Now, this right here has the information we need. We can get our static mesh here, and we're gonna have to use the same trick. So we're just going to copy this here, plug it into cast succeeded, sorry, make sure you do succeeded, not failed. And once again, another cast to static mesh right here, the basic static mesh, make sure it's not the static mesh actor, just the basic one. And from here, we can now get a, well, actually, from here we can do nothing because I haven't set up a static mesh yet. So in our components here on our A build, we want to do add static mesh. So all the way at the bottom here, add it here and make sure it is not replacing the default scene root, but as a child attached to it. So now with this, we can say set static mesh to our new static mesh that we found. Like this, it is now completed. Now if we do our play again, if we press 1, it actually appears. We have our floor, just as name indicates, and it is exactly the same static mesh that we created or attached to it right here. Now, the next thing we want to do is we want to make it move. And to make it move, we need to do one thing first. We need to actually save this reference here, because until now, we didn't have a reference to it anywhere else, so we didn't know which actor we would try and move after this. So compile that, and now, just to make sure things are smoother, you don't have to do it this way. It probably would be better to do this with a timer, but so that the movement is more fluid, especially when we're doing it in free movement, we want to use the event tick. Now, I'm sure many people going around have seen event tick is bad, and that is true, but it's mainly true if you're overusing it. If you're using event tick on one actor, it's not too much of an issue unless that event tick is extremely demanding in what it needs to do. But in our case, we're just going to be doing a line trace and a bit of math, which is quite light as far as it goes. And because it's only on our AC tools and there's only one actor in the entire world using it, it's fine. It won't be a problem. So all we want to do here on event tick is the first thing is we want to make sure that we don't do anything if we don't have an actor that is trying to move. Sorry, no. We're not going to do it like this. Or actually we will. We'll just right click here, collapse the function, and this is going to be called UpdateBuildLocation. And this is from kind of testing. Sometimes if you have the check here, the get is valid, placed here, it will still pass this and actually run this logic sometimes. So I'm not sure why that was, but from my testing that happened. So just for safety measures, we only want to run what's in the rest of the function if this is true. So it's pretty much the same thing, just inside instead of in front of the event tick. So there's two things we need here, and we're just going to do a sequence to keep things a bit tidier. On the end here, we're going to add a reroute, and we're going to turn it into a function as well. We're going to right click, and this is going to be called can place build. And this is going to be a very, and I really mean this, a very rudimentary version of checking if an actor can be placed by doing a box trace around its bounds. So it's not perfect, but it's an easy way to test if a cube or a platform or anything kind of very simple in shape can be spawned in a location. So we'll leave this here for now. What we're mainly going to be doing here is we're going to be doing our line trace because we need to know where to move our actor. So we made a macro for that. So our line trace by channel forward, we're going to break this, and very simply, we're going to get a reference to our building reference, and we're going to say set actor location, just like this, plug it in, impact point, and just like that, we are done. We have finished our movement. It was that easy. Oh, no, not that easy. Sorry, I made a mistake. Getting ahead of myself. One thing we do need to also check here is we need to make sure that this static mesh cannot be hit by the line trace. So to avoid that, we can go into our line trace by channel here, and this will be a bit of a mess because the macros sometimes just push everything together. We're going to tell our actors to ignore, to make an array, and the only thing we want in the array is our building reference, that we don't hit the building itself. So normally now, if we go and do the same thing again, we have our little building here that can move around, and obviously if we go too far, it will reset itself to 0 because it considers that we're not hitting anything. So right here, we can move it no problem. But if we hit ourselves, it will push us away because we are still using the collisions on it. Now, we are going to solve that very quickly because we actually need to do that as well. Otherwise, it might block or push any physics objects, which we don't want because it doesn't actually exist yet. So back in our A builds, static mesh, go down, and we're just going to say no collision. So what does this do? It will just change. Actually, sorry. So we're going to put custom, and we'll put this to no collision and everything else to block. But because no collision is happening, it should just ignore the character if I'm correct. There we go. So now it can go over the character, no problem. It doesn't block us or cause any issues, doesn't send us flying. So back in our AC tool, we need to now make it so that we can do the snapping or the grid snap. So to do that, we need our input. So we're going to get our grid IA right here. So place it here, and on started, on started, we're going to make a variable. So right here from our action value, we're going to promote a variable, and we'll call this is using grid. And detach it, we just want to use it to create. On started, it is true, and on cancelled or completed, it is false. It's simple as that. We don't want to do anything else here. And if we go into our update building grid, we will drag this a bit further, and we will use a select vector node, and we'll use is using grid right here. Now, if it is using grid, we don't want to use that. This will go into our new location, by the way. If we're not using grid, we want to use the impact point. If we are using the grid, so if is using grid is true, we pick A, so this one right here, we want to say snap vector to grid. And here you can put whatever you want. I'm going to put 500 because that's the size I used when I was making the different assets. So right here, if we close this, we now have a perfectly working, I hope, I'm not going to make a mistake again, grid system now. So if we hold control down, we should get a grid. So if we do 1, our item just moves around no problem. But if I hold control, it only moves by units of 500. Now, one thing we do need to change is because, as you can see right now, it may look slightly rotated. And we're going to make it so that the grid also takes that into account and handles the rotation to be more towards 0 if we're holding control. Now, to do that, we need to add our input for rotation as well. So right here, we're going to look for IA, rotate. For the rotation, what we're going to do, first, we need to check if we have a building. So once again, we'll drag in our reference, we'll right click it, and we'll say convert to validated, start it, and right here, we'll use this to add actor rotation world. And this is going to be how we handle most of it in here. So we're going to split this because we're only going to be rotating on the Z here, because in most cases, I feel like you never really rotate on the Y and X when you're handling building or buildings. So I'm not going to touch the X and Y in this tutorial at all, but we're going to be using this one mainly. So with our is using grid, we're going to tell it how to handle this information. So our action value goes from -1 to 1, -1 being negative, 1 being positive. So that means we increase or decrease based on this result. Now, how we're going to do this is we're going to use a map ranged clamped. And what this will do is we will put -1 for A and 1 for B. And what this means is whatever value here we have will come out as this. Now, normally we could just say, oh, well, this is 10 and this is -10. And that would, or sorry, the inverse, -10 and 10. That would work. But the problem is, if we want to snap to grid, we want to change it. We don't want to use the same value. So we're going to use our grid to select a float. And if the grid is true, so pick A, we're going to use 90. Now, if the grid isn't, we're going to put 45. And we're going to say multiply here by this. Sorry, no. We're going to plug this directly into B. But for A, we're going to use the negative, so -1. So this is what it should look like, -1 to 1. And here, -1 because it's the negative of A, or the same value as A it's going to use, and otherwise B will use this. Now, if it's using a grid or using the grid, we use 90, otherwise you use 45. So let's try this again. And now if we press 1 and rotate, it rotates by about 45 degrees, but if we hold control, it will rotate by 90. So it's not visible here because it's quite literally a cube, so you can't really tell other than the rubbish UVs that I made. There we go. So that does it for the movement. Now the final thing we need to do is the placement. And we also need to do the check if it can actually be placed. The next thing we need to do is we need to add our IA for confirm, because we need to know if we want to keep this location fixed. So for confirm, there's a few things we need. We need to check this if it exists, because if we're confirming something, we need to know that it is actually valid. So on started, is the item valid we're trying to place? If it is, we want to do two things. Normally what we could do here is we could just say, well, here, set building reference here to empty. And what that will do is, let's just show you, if we press 1 here and we press left click, it'll place it and we won't be moving it anymore because we've just told it that that building is no longer connected to the player, so it doesn't exist, or no longer connected to the component, so it doesn't exist, so we don't move it. Now, there's a few extra things we need to do to get this to work properly, because right now this is nice and all, but what happens if it is overlapping with another object? Then we don't really want it to place because it shouldn't be allowed to place. Now we have a function for that, and that we're going to get right here. And as I mentioned previously, it's a very, very rudimentary method to check whether an item is safe or not. Not safe, sorry, can be placed or not. So to do it, we're going to have a box trace by channel. A basic one, because if we hit one object, we stop. Our access to ignore we actually need here, because we're going to say make array. And make array is going to be with our building reference, because we don't want to hit the building itself. And normally you would have ignore self, but this is being called in our actor component and not in the building itself. So with the building, we now need to say, but to be fair, this is probably better off inside of the building. So we're actually going to change this. I'm actually going to go off script here. So we're going to delete can place building right here. And where it was placed in our update build, which was here, we're going to get a reference to our building reference and say inside of here that we want to check if we can build. So can place build. There we go. And just while we're at it, we want another variable, which is going to be called can place build. Oh, sorry, can't use that. Is valid placement, we'll call it. And this is just going to be a Boolean, which is going to be true or false based on the results in here. So just to call it back in our ACs that we don't forget, is can place build. So it's pretty much going to be the exact same function. It's just that we'll have it inside of here to avoid all the unnecessary references and lines that kind of get annoying. So what we need is we need our static mesh here. We're going to get local bounds. And what this will do is it will get kind of the local bounds, so relative to this instead of in world. This kind of avoids the issue of if you're drawing this box, if you would do it with, let's say, this one right here, which we're going to use as well, component, right here, get component bound. This one doesn't work. This one is in world space. And what this means is that this box extent doesn't take into account the rotation. So it is a lot bigger if the object is rotated like 45 degrees. So we need to use this one to take that into account. Now, our origin here is in local space. Sorry. Now, the reason we need to use this and not get actor location is because if we look at our pivot point on our our asset here, our floor, the pivot point is actually at the bottom. So if we show, I believe, show pivot, it's at the bottom of the mesh. It's not in the center. So our origin right here will get that information as the center. So right here is what we're going to use. And we need to make sure that this is in world space. So we're going to get actor transform and say right here, inverse transform location. And this will take our local value here and turn it into a world space. Let's just pull up our our box trace by channel so we can start connecting stuff up. Here, we don't need to call our actors to ignore because we're ignoring self. It's just fine. We're also going to get a reference to our rotation here. So get actor rotation because our orientation is exactly the rotation we're using here. And this right here, this value is going to be the half size. Now the half size is the max right here minus our world position value here. Because what this will do is it will actually put a point in the top right, I believe. And this is in the top or the bottom left. So these are kind of the max and mins of the bounds. And this is in world space. So if we subtract this, our maximum, from our origin, then we get our half size. Now, we don't want to use the half size just like this because it would be right on the line. And if it's right on the line, two objects that are snapped perfectly together will kind of stop themselves from building. So we're going to make it slightly smaller by adding a multiply and converting this to a float. So right click the pin and convert to float. And we'll put 0.88 is what I found to work. You're free to play around with this if you want. And the last thing we need is our origin right here. We're going to reroute it and plug it into our start and our end. Sorry, let's just add another reroute here. Oh, not that one. There we go. Sorry, I think I made a mistake in explaining this earlier. I said this turns it from local to world. No, this is world to local. So this is already in world space, but we need it to be local because this is in local. So that we just get the distances correctly for the half size. So I made a mistake there. Sorry about that. All we want to do is say, well, if this hits something, then it is not a valid placement. So we'll put not Boolean here to let it know that it cannot be placed right here. So compile, save. And now if we check our event graph right here, we can actually perform that check. So we can say, is valid placement, because the other one is getting called on tick, so we don't need to actually call it again here. And if it is a valid placement, so on true, then we'll be able to say place the build, and we'll call this here to cancel it, but we're going to add one last thing in a second just to make it a bit nicer. So if we play, sorry, let's just make this visible so that we can check. So for one frame, because it's going to be happening every frame. So 1, and normally it should be appearing, I believe, but we just can't see it. Yeah, it's inside. So if it's red, that means that it's not hitting anything, and that's good because it's not hitting itself. And what that means is if we press play here and click, it does indeed place, and we're done. Now, one thing we can do to just double check is we're going to add another 4 here. We're going to do our 1 here, and if we try and place here, it shouldn't work. No. So if I'm spamming here, it isn't actually placing because it knows that there's something in the way. But if we put it to the side, it works just fine. So the final thing we can do just to make this a tiny bit nicer is we're going to add some actual materials, because right now it's difficult to tell that we've placed or haven't. So what we'll do is we will say a new folder for materials. And we're going to make one material, which is going to be our hologram. We'll call it, oh, not M nothing, M underscore hologram. And very simple, open it up, change the material domain to, sorry, not the blend mode, to translucent. Press 4 and click, and that'll just be our base color and our emissive. And this is just going to be by default, we will say green. And our opacity, sorry, we need to change it to 0.6, I think we'll do. Or maybe 0.4, and I think we'll remove the emissive, just like transparent, simple as can be. Now we're going to make a material instance of this. So close that, and we'll just right click, create material instance, mi hologram, and we'll call it underscore red, just to say that it cannot be placed. So, oh, sorry, that's my mistake. I completely forgot. We need to turn that into a parameter. So on our constant in our hologram, right click, convert to parameter, color, and there we go. So apply this, save, and now in our hologram red, we should be able to change the color. And so that will be red. So 0 here, 1 there, 0 there. And we can close this. And so just to make things better, in our builds here, we're going to say set our static mesh material like this based on our actual selection on our is valid. So select from our material, and we will get our is valid, plug it into the index. Even if it looks like an integer, it actually accepts a few other things. False, we will put our hologram, such a hologram red, and on true, we'll put a hologram green. And now we need one extra thing because of this, because now if we, let's say, run this and we do 1, it says green, it's okay. If we place, it stays green, and that's not good. We want it to actually place itself. So we're going to make a function for that in abuilds place building. And inside of it, what we're going to do is we're going to say set material for our static mesh. So you can type that, or you can drag from here and type it as well. And we're just going to use the basic material. So we're going to use the default of Unreal. So just this one right here. And if you want, you could, in our data asset, save a material for it. That would work just fine. You just plug it in here, and it would set itself to that. If you have multiple materials, you just do a for each loop with them instead. Another thing we want to do is we want to say to re-put our collisions. So we're going to say set collisions enabled. And right now, if we look at our static mesh by selecting the components here, if we look, everything is blocking, but our collisions are not enabled. So we want to change this here by saying set collisions enabled, and we'll put it back to physics and query, so collision enabled. So place that here, and I believe that should do the trick. Now we just need to call this right here. So if we can place it, we're going to get a reference to our building before we delete it, and say place building. And just like that, we should now, when we spawn, it is green. If it overlaps us, it doesn't matter, it doesn't consider it. If we place it, it goes back to its default color. And one last check we can do is if we add a static mesh somewhere just to block it, let's see what happens. Does it become red? It should. There we go. So once that little green, once that becomes green, which is the inverse of what's happening, it means it hits something, and if it doesn't, it's green. If it does, it's red. So as simple as that. We can't place here because it's not allowed because it hit something. But if we move it here, it places just fine. Now, if we do also the same, obviously on top, it works as well because the little red box is slightly offset from all the edges so that it appears correctly. So we can close that. And that'll do it for part 1. That took a lot longer than I thought. I hope everything is clear. I hope, even though I took a bit of extra time, I hope everything is clear about kind of the process, not just about how to do it, because it's not that difficult. But I hope you enjoyed. I will see you in the next part. Thank you for watching. Goodbye.